Okay, the next bit is on multiplying surds. So we've had a look at simplifying them, then we've had a look at adding them together, and now we're going to look at this rule which has to do with multiplying them together. So the coefficient, the a and the b, the numbers out in front, simply multiply together, and the parts underneath the square root sign or underneath the root sign, they multiply together and stay underneath the root sign. So if we have a look here, multiplying some actual numbers, root 2 times root 6, they're both under a root sign, and we just get root 12. Root 5 times root 7, root 35. We multiply the 4 and the 3 together to get 12, and the 2 and the 5 underneath the root sign gives us root 10. And this one here we get 24 root 112. So all of that's pretty straightforward. The tricky part to these is usually we're not only asked to multiply them together like I have here, but I'm also asked to simplify them. Now we've already been through how to simplify surds. Have a shot and see if you can simplify these. Simplifying those wasn't too bad. The first three were quite easy. So we saw in the first one root 12. If we use our trick of drawing up our factor tree, then it pretty simply splits into a square number of 4 times 3, and we can then simplify the 4 root of 4 to give you 2 root 3. Another kind of shortcut that you can use is when you go back to these original two numbers, rather than thinking about what does 12 break up into, we can break up those smaller numbers. So that's 2 times 2 times 3, which gives you the clue that you can put the 2's together to get 2 times 2, 2 squared. And you're going to get that 2 coming out. So in this more difficult example down here of 24 root 112, what I'm talking about is I can split back here the original part, the 8 and the 14. 8 into 2 times 2 times 2, 14 into 2 times 7, and now it's a lot easier to see that if I group those two together, so I'm going to have 16 times root 7, which gives me my 4 root 7. So if you want to work with the large number of 112 and then use a factor tree to try and figure out what the square factors are for that number, then you can, but don't forget that back in these original pair of factors, you can find the clues to what the square part of the number would be by breaking up those smaller numbers, which are a lot easier to work with. So once I break root 112 into 4 root 7, it becomes 24 times 4 root 7. 24 times 4 is 96, so it's 96 root 7 is my final answer. Don't forget, if you just type that into your CAS calculator, it'll spit that answer straight out, so you can always check your answers pretty easily by just putting in the original question. Here are a couple more difficult examples. So again, the parts under the square root sign we multiply together. 5 tens are 50. Use our index laws to say a cubed times a gives us a to the power of 4, and b squared times b cubed gives us b to the power of 5. Now that we've got those two all combined, I can look to split out any parts that I can square root. So I can split 50 into 25 times 2. The 25 comes out as a 5. A to the power of 4 is a squared squared. So if I square it, it halves the power. The power becomes a squared. Likewise, b squared times b squared gives me b to the 4. So if I split that b4 out and have it as b times b4, I can square root b4 and it comes out the front as a b squared. The 2b stays behind. I can also do the same sorts of things with division. If I have a problem like this, I can simply divide any numbers that are under a square root sign, which is all of them. So the 20 and the 10s cancel by dividing both top and bottom by root 10. Divide top and bottom by root x, drops the power of x on each one, and divide top and bottom by a root y, drops 1 off the powers of y. The top becomes 2 times 1 times y, which is just root 2y. The bottom becomes 1 times x squared times 1, it's the square root of x squared, which is just x.